Again, what we're doing in this problem in an example A on 7.8 is we're trying to factor this x to the fifth minus 6x to the fourth, blah, blah, blah. That's our big polynomial, and we're trying to break it up into two factors. Just like you can break up the number 8 into 4 times 2, or the number 15 into 5 times 3, or x cubed. You could break that up into x squared times x, right? You can always factor, you can usually factor something into two pieces. Well, we know, based on looking at the roots or the zeros over here, that one factor is x minus 1 because of this 0. And we know that since it crosses at 2, we have an x minus 2. And since it crosses at x minus 3, we know that x minus 3 is a root. Okay? So here's what we're going to do. We're going to try to figure out what the missing part is by doing long division. So what I want you to do is make a big long division bar. And under the bar, under the green bar, is called the dividend. That's going to be the polynomial that you're trying to factor. So write out the original problem under there. The divisor, which goes out in front of the bar, is going to be the part that we already know. But I don't want you to write it in factored form. See, we know it as x minus 1 times x minus 2 times x minus 3, but I don't want it to look like that out there. Instead, I want you to write this divisor out front in its expanded form. And here's what I mean by that. I want you to tell me what x minus 1 times x minus 2 times x minus 3 is if you expand it. Here's what I mean. FOIL these two, then multiply by the x minus 3. To do this process, it's better to not have that divisor in factored form. Instead, what do you get in green here? Here and here combined. And then last. Very good. So I FOILed the first two factors. Now I need to multiply them by x minus 3. This is kind of like a super FOIL. You don't just FOIL, you have to FOIL and then FOIL again. But this next part involves x squared times both of these. We've seen this before in this class. Hope you remember. Then negative 3x times both of these. And then finally, 2 times both of these. Go. X squared times x. X cubed. X squared times negative 3. Negative 3x times x. Negative 3x times 3. Again. Positive 3 times 3 is 9x. There we go. Finally, 2 times x. And then does anything combine to simplify this a little bit? These two? So I got the x cubed out front, and then negative 6x squared because of this. These two? Minus 6. Now that we've expanded that, this is what we use as our divisor. So take x cubed minus 6x squared plus 11x minus 6 and put it out here. So we're going to have x. That's the wrong thing. So we should have an x cubed minus 6x squared plus 11x minus 6. So at this point, you might be thinking, I want to go home. Or Wow, we've come a long way since 8 divided by 2, right? This is much, much more involved. It's much more involved than anything we did on our warm-up here. But if you just take it piece by piece and slow down, you will be amazed at the answer and how easy the answer will look. I know there are a lot of terms here. There's x to the 5, 6x to the 4th, right? There are how many here? 6, 4 more. There are 10 terms staring at you, right? The only two you need to focus on right now are this one and this one. Look at the lead terms and just tell me, what times x cubed will make it x to the 5? X squared. Put that directly above the x to the 5. Let me recap that. Is x squared the key? Is x squared times x cubed x to the 5? Yes, because you add their exponents. That's the only thing you had to focus on there. Now you get the ball rolling by figuring out all the stuff that goes under here. So take your little answer here, x squared, multiply it here, 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 and here, and write those answers here. Okay? Go. X squared times x cubed. X squared times negative 6x squared. 2 and 2 makes 4. X squared times 11x. We didn't get a match there, but it's not the end of the world. It's okay. And then x squared times negative 6. Negative 6x squared. So now that we have that blue line there, we simply subtract it from what's in green. What's x to the 5 minus x to the 5? So don't even write it if it goes away. It's 0. What's negative 6x to the 4th minus negative 6x to the 4th? No. It's like saying, what's negative 6x to the 4th double minus makes it plus. That's 0 as well. The first two are gone. Then 20x cubed minus 11x cubed. Keep things lined up. Then negative 60x squared, double minus makes it plus 6x squared. Negative 54x squared. Usually, you then bring down the next digit in long division. In this process, you bring down both of these. Bring everybody down. And then start the process over again. This will be the last of the processes, though. All right? Because look, what times x cubed makes 9x cubed? Just look at the beginning here. Only focus on the beginning. You're right. It's 9, right? What times x cubed makes 9x cubed? 9. Positive 9? Then put a plus sign between them. We asked ourselves, x cubed times what makes 9x cubed? So we needed a 9 up there. Okay? You got it. Since it's positive 9, it's plus. Now, same thing we did before. This number up here needs to multiply by here and here and here and there. But wait until you see what all those answers are. They're all going to match. What's 9 times x cubed? 9x cubed. What's 9 times negative 6x squared? Look, a match. No. What's 9 times 11x? Positive 99x. And what's 9 times negative 6? negative 54. And when I put a big line under this and subtract the whole thing, what's the remainder? These cancel, these cancel, these cancel, these cancel. The remainder is 0. So this is what we were missing. I just want to say this. When we do 10 divided by 2, what is it? 5. That means that 10 equals 2 times 5, right? In this problem, we knew that this giant polynomial was equal to this red box, now it's green, times something. Division helped us find that missing something. So that missing something is x squared plus 9. Why didn't we see a 0 there? What squared plus 9 in the real number system could make 0? 3 squared plus 9 is 18, right? Oh, maybe it's negative 3. No, because negative 3 squared is 9. 9 plus 9 is 18. So the question is, where are the other two roots? They're imaginary. One is 3i, the other is negative 3i. Now, the last thing I'll leave you with is this now a valid fifth degree equation when you see it in this format? How many x's do you see? 1, 2, 3, 4, 5. X to the 5. Okay?